All right, let's talk about something really cool. The private highways of the internet. We're diving into MPLS, which is this amazing technology that lets big companies build their own super fast, super secure networks all over the globe. Ready? Let's jump in. Okay, so picture this. You're a huge company, right? You've got offices in Mumbai, Delhi, Bangalore, maybe even farther. How in the world do you connect all of them so that the data they share is fast, totally private, and doesn't get stuck in some kind of digital traffic jam? Well, that is the exact problem MPLS was born to solve. Think about the normal public internet. It's like a massive, chaotic public highway. It's open to everybody, which means, you're going to hit traffic. It's unpredictable. And you're sharing the road with, well, everyone. Businesses can't deal with that chaos. What they really need is their own private express lane, a network that's always reliable, always fast, and completely walled off from all that public mess. So here's our game plan. We'll kick things off with the big problem businesses are trying to solve. Then we'll use a pretty simple analogy, a virtual mailroom, to make sense of how MPLS works. After that, we'll peek under the hood at the network core, see exactly why MPLS beats the regular internet, and then wrap up with how you can connect to this private highway from pretty much anywhere.
So, Section 1, the private network problem. Why isn't the public internet always good enough for business? The core issue is this. Businesses need that private highway. But you can't just go laying new fiber optic cables across the country for every single customer. That's impossible. So what's the solution? Well, this is where the genius of MPLS really shines. It's a technology that lets a service provider take its one massive network and slice it up into countless, completely separate virtual private networks.
All right, Section 2, a virtual mailroom service. We're going to use a simple analogy to understand MPLS. To really get a handle on this, let's imagine the provider's whole network is one giant office building, and all of their customers are different companies just renting out floors. Now, they all have to share the same hallways and elevators, right? But their internal company mail, that has to stay 100% private. Well, MPLS is basically the building's incredibly efficient and super secure mailroom service.
So step 1, the packet arrives. The journey starts the second a data packet, let's say it's an important email from your Mumbai office, leaves your company network. It travels over to the provider's network and shows up at a very special router, which is our mailroom. In the real world, we call this the provider edge router, or just PE router for short. Now, the moment that packet hits the door, the PE router, our virtual mailroom clerk, instantly knows it came from your company. And the very first thing it does is place it into a private sorting bin that's just for you. This bin is called a VRF, or Virtual Routing and Forwarding Table. It's basically a virtual router that only handles your company's traffic. This is the absolute key first step to keeping your data totally separate.
Okay, step 2, making the address unique. But wait, we've got a problem. Your company might be using the exact same internal IP addresses as another company in the building. From the network's perspective, it's like two different companies both have a finance department on the second floor. So how does the mailroom avoid sending your sensitive financial data to the wrong company? You've got to find a way to make that generic address totally unique.
And that is exactly what the route distinguisher, or RD, is for. The router takes that internal address and basically stamps it with a unique company ID. So, Finance Department suddenly becomes Company A's Finance Department. Just like that, the network sees a globally unique destination. That's it. The RD's only job is to make sure every address is unique, period.
All right, step 3, adding delivery instructions. So the address is unique now. That's great. But how does the network know which of your other offices should get this email? You don't want the data from your Mumbai office accidentally showing up at some third-party site you work with, right? Nope. So for this, we need to add some very specific delivery instructions, kind of like a mailing list.
And this is where the route target, or RT, comes into play. You can think of it as a special sticker that says, deliver only to Company A locations. Now, as that packet flies through the network, only the routers that serve your other offices are configured to accept mail with the Company A sticker. Every other router for every other company, they just ignore it. It perfectly defines who's on your private network's mailing list and who isn't.
Okay, Section 3, inside the network core, the technology behind the mailroom. So the mailroom analogy has gotten us pretty far, but what's actually happening under the hood? Let's peel back that layer and look at the real hardware, the specialized routers that make up the provider's powerful network core.
So the network has this really smart division of labor. You've got the PE routers we've been talking about. They're the brains of the operation, sitting right at the edge. They handle all the complicated customer-specific stuff, like the VRFs, RDs, and RTs. But deep inside the network core, you have what are called P routers for provider routers. And these guys are pure muscle. Their one and only job is to forward packets at unbelievable speeds. They don't know anything about customers, and they don't care. They're just built for speed.
So how do these muscle P routers move data so incredibly fast? It's all thanks to this elegant little three-step process called label switching. Here's how it works. Step 1. When your email enters the network, that brainy PE router pushes a simple number onto it, a label. Think of it like a temporary shipping sticker. Then, Step 2. As it zips through the core, each P router does a super fast swap, just replacing the incoming label with the next one for the path. This is way, way faster than having to read a long, complicated address every time. And finally, Step 3, the last PE router in the chain simply pops the label off and the packet is back to its original state, ready for delivery. Section 4. Why MPLS beats the Internet. The core business advantages. Okay, this all sounds pretty clever and technical, but at the end of the day, why would a business pay good money for this service instead of just, using the regular Internet? Let's break down the core advantages that make MPLS the go-to choice for so many companies. And really, this table sums it all up perfectly. With MPLS, you get guarantees. Performance is consistent and predictable, security is baked right in because of that isolation we keep talking about, and you get total control over your traffic. Now compare that to the public internet, where everything is best effort. Performance is variable, it's public by nature, and your critical video call is just fighting for bandwidth with everyone else's cat videos.
That first point, guaranteed performance, is huge. What this really means is that MPLS providers give you a contract. It's called a service level agreement, or SLA. And in that contract, they literally promise your network will perform at a certain level. That means no random delays, no stuttering, no lag. And for real-time stuff like video calls or VoIP phones, that's not a nice to have, it's absolutely essential.
Then there's the security, which is a massive selling point. Because your traffic gets sorted into its own private VRF the second it enters the network, it is fundamentally isolated from everyone else. Your data never, ever touches the public internet while it's on the MPLS network. It's like your data is traveling inside a sealed, armored truck on a completely private road. It's just separate from all the threats out there.
And finally, you get total control. This is done with something called quality of service, or QoS. Think of it like having an HOV or VIP lane on your private highway. It lets you tell the network which applications are the most important. So you can make sure your critical video conference gets top priority and a silky smooth ride, even if someone in another department decides to start downloading a gigantic file. You're in the driver's seat.
Okay, last section, connecting from anywhere. Secure on-ramps to your private highway. Now, this private highway system is fantastic for connecting your big corporate offices. But what about all your remote workers or smaller branch locations? You're not going to build a whole new highway exit for one person's home office. So, how do they get secure access onto the highway?
Well, there are basically two main types of on-ramps they can use. First, you have an IPsec VPN. This creates a really secure always-on tunnel. You can think of it like giving a trusted employee a corporate car with a special key. It usually requires some client software on their company-managed laptop, but it gives them full network access. On the other hand, you've got an SSL VPN. This is more like a temporary day pass. It works right through a web browser on pretty much any device, so it's perfect for, say, a contractor who needs to log in for a few hours from a hotel computer. And that really brings us to our final thought for today. MPLS was built to be this ultimate private road system connecting corporate buildings together. But now, in a world that's moving so fast towards the cloud, where so much business traffic is going to public services like AWS or Azure, is the idea of a purely private highway still the king of the road? Or is the future more of a hybrid approach, mixing public and private roads together? Honestly, that's the big question that network architects everywhere are grappling with right now.